Alrighty there, folks. We are going to be looking today at rational exponents, which is what that title there is. And rational numbers, if you remember, are numbers that can be expressed as fractions, but they also can be either repeating or terminating decimals. So in other words, expressed as m over n, where m and n are integers, so -3, -2, -1, 0, 1, 2, 3. So long as n doesn't equal 0, you're all good. Okay, so that includes then terminating and repeating decimals. So let's look at some examples. We saw one today in class about a rational exponent. Let's look at that one or something like that really quickly here. Something like 25 to the power of a half. Now let's take that and multiply it by itself, like so. And because we have the same base, we are simply multiplying powers. And if we multiply powers, we add the exponents. So the answer here is just 25 to the power of 1, which is the same thing as 25. So if 25 to the power of a half times 25 to the power of a half equals 25, what the heck does 25 to the power of a half mean? In other words, what times itself equals 25? Obviously, the answer is 5. So 25 to the power of a half is the same thing as saying 5, because 5 times 5 is 25. 25 to the power of a half is 20 squared is 25. So they must be the same thing. Let's see if that works with a different number. Okay, 9 to the power of a half times 9 to the power of a half is just going to be 9 to the power of a half plus a half, or 1. And so, sure enough, this just means 3 times 3, okay, which is 9. Okay, well, let's look at a different rational number. Let's look at a rational number 1/3 instead of 1/2. Okay, so 8 to the power of 1/3 times 8 to the power of 1/3 times 8 to the power of 1/3. Again, the same base, we just add the exponents. 1/3 plus 1/3 plus 1/3 is 3/3, or 1. So that means then that 8 to the power of a third is going to be something that multiplies by itself 3 times to get you 8. In other words, the answer there, x is going to equal 2. Okay, so in the previous example, 9 to the power, 9 to the power of a half is equal to 3. In other words, the square root of 9 was 3. Here we have 8 to the power of a third, and it's the cube root of 8 is 2. I think we might be onto something here. Let's see if we can summarize that. And here it is here. X to the power of 1 over n is simply the nth root of x. So all those examples we talked about were displaying that same relationship. Let's look at them again really quickly here. There they are there. Okay, so this 2 we typically don't write. When you write the square root of something, we don't write a 2 there. Kind of like we don't write 1 as an exponent. It's understood, it's just there. So I don't typically write the 2 here, but there is 1 there. We just don't typically write it. And then when there's something besides 2, like 3, we definitely write that one. Okay, and so we can extend this beyond the half or third, like at, say, fourths or fifths. So 16 to the power of 1/4 is equal to the fourth root of 16, which is what number multiplied by itself 4 times. So something times something times something times something equals 16. And you can put that into your calculator, actually, and figure out the answer is, in fact, 2, because 2 times 2 times 2 times 2 is 16. Okay? So on your calculator, you can either do 7,776 to the power of the fraction 1/5, or you could also do to the power of 0.2, because that's the same thing as 1/5, or you could do the fifth root of 7,776. Either way, you'll get the same answer. See if you can do it on your own. I'll give you 3 seconds. Okay, so you should have got the answer was 6. All right, and if you didn't, then we'll bring your calculator to school tomorrow, and we'll make sure you know how to do that. So rational exponents kind of work in that way, but they follow all the other same exponent laws. So something like this might look really scary, okay? But if we follow the same exponent laws, that is, we're multiplying powers. So multiply powers, you simply add the exponents. and that's equal to 3 to the power of 0.2. Okay, and again, that's a rational exponent, so you could think of it as 3 to the power of 1/5, because that's the same as 0.2. But on your calculator, you can figure them both out, and you get the same answer, whatever that answer is going to be. I think I actually meant to put in there a different base, like 243, because the fifth root of 243 is 3, but whatever, too late now. Okay, they mean the same thing. But since we're doing 3 to the power of 1/5, or 3 to the power of 0.2, it's just the fifth root of 3, which is 1.246, and a bunch of other numbers. Okay? Anyways, so there's that. Let's look at some other examples here. Okay, this one looks really scary, but follow the same exponent laws. We're multiplying powers here, so all you're going to do is keep the base the same and add the exponents. Okay, so add 13 over 30 plus 1/6, and then see if you can figure out where to go from there. I'll give you a second to do that next step. Okay, so hopefully you paused the video and you figured out that the answer is either 1024 to the power of 3/5 or 0.6, same thing. How do we get that? Well, just by adding fractions together. So find a common denominator, which in this case is 30. There you go there. Oh, but Mr. Beebe, I can just use my calculator. Well, you know you can't always do that, so make sure you can do it both ways. Okay? So anyways, there's my answer, but what does it mean? Well, what I want you to do is I want you to right now put in 1024 into your calculator, raise it to the power of 3 over 5 or 0.6, and see what the answer you get is. Okay, you should have got 64. Okay, I didn't give you a whole lot of time there, sorry. Anyways, hopefully you can do it and you get 64. But we know 64 is kind of a special number, so there has to be some kind of way where we can figure this out and see how we got 64. So let's break this down a little bit and see what happens when we look at that this particular expression here a bit more. Okay, well, remember we talked about negative exponents? We said we could take a negative exponent and break it up into -1 times something else. Like the exponent -3 would be the same as x to the power of 3 to the power of -1. So power over power, you're going to multiply exponents, get the same thing. We can do the same thing with this fraction, this rational exponent as well. Because the exponent 1/5, you know, is the fifth root of something. We don't know what 3/5 is, though. So let's just take out that 1/5 first, make this a power of a power, and if we split it up in the same way, we get the fifth root of 1024, whatever that answer is, cubed. Okay? Now, on your calculator, you'll see really quickly that the fifth root of 1024 is simply 4, and 4 cubed is 64. So that's why we got the answer that we did. So it's really good to have some practice doing that, where you break up a rational exponent into something a bit more manageable. So that's what your homework questions are going to be. Here they are. And for each of the questions I'm about to give you, what I want you to do, for example, for this one here, if this was your homework question, which it's not, okay, I want you to break it up into a power of a power. So you're going to go 512 to the power of 1/3, okay, and then raise that answer to the power of 2. Okay, and so you would do that, and you go, okay, well, the cube root of 512 is 8, and so you'd write, okay, well, 8 squared is, again, look at this, 64. Okay, so that's how this is what I want to see in your homework questions, okay, when you're going to bring that to class for me tomorrow. Okay, so there are your three homework questions. Okay, again, write out the solution the way I did for the previous one. Okay, break them up into different powers of power so you can evaluate it. 625 to the power of 3 over 4, 128 to the power of 3 over 7, and 59,049 to the power of 0.3. That last one's a tricky one, but you can do it. I would recommend you convert it to a fraction, don't leave it as a decimal like that. All right, and then we'll go over those tomorrow in class, and you'll get marked for doing it. So I'll see you all tomorrow.